Okay, when dealing with accuracy, it helps if you're going to use a calculator to know kind of what your answer should be around. So if I was going to multiply 399, and I knew I was going to buy 5 of those things, okay, I would just take 4 and multiply it by 5, get 20, and say my answer should be about 20. Okay, so I would go ahead and approximate it in my head, and then when I get my answer, oh, does this make sense? Okay, so if you're going to use a calculator, absolutely okay, but you better be able to understand that if it asks you how many members are in this group, and you get 13.2, that's probably not right, because you can't have 13.2 of a member. Okay, so that's part of our introduction into this. Be careful of what you are doing so that you know what your answer should look like. All right. Doing actually has to do a lot with estimations and rounding. So I'm just going to go over a quick bout of how to round, when to round, and what we do. So quickly, let's round this to the hundredths place. Hundredths with the TH. Okay, so it's going to go rounded to this. Do I round it up or down, and why?
Down.
I'm going to round it up because it's 5 and up, round up, right? So to round this, it's going to be approximately now, because I rounded, 3.13. Now another similar number, what if it's 3.9987? And I said round to the hundredths place. Again, I'm rounding to here. I see that that's a 8, so I need to round up, right? So this rounds to, 0. I got to carry my 1. That becomes a 0. Got to carry my 1, right? So I end up with 4, even though I rounded to the hundredths place. Here's what's important about rounding to the hundredths place. If it says round to the hundredths place, you still have to write those hundredths place in there. Okay, so still going to 0.00. Any questions about that? Okay, so just as a quick review, because I have a lot of questions about this in Algebra 1, let's just write down a number, 3.1234. Okay, we're just going to underline each number. Then I'm going to draw arrows. So the first one is tenths. Second one is going to be hundredths. And I will warn you right away that I am terrible at English, so there's a few times that I'll spell it 15 different ways to see what it looks like. And half the time I'll still be wrong, so if I am wrong, please correct me. I will not take offense. This one would be the thousandths. Three goes to the thousandths, and then the fourth decimal place is going to be the 10 thousandths. Say that again. Oh, you're sorry. Yes, you are correct. Still terrible looking, but thank you. Okay, so typically we never say thousandths after that because nobody wants to deal with that, and they end up putting it into scientific notation. So there's very few times that I've seen 10 thousandths, but you need to know the differences between them. Okay, now everybody should know the ones place, the tens place, the hundredths, and the thousand place, so be careful. Did not get those confused with the ones with THs at the end. Alright, so I want you to look at that chart where it says Dan's dinner, or dinner, yeah, there you go. So, if I'm reading this, I wanted to just get a quick approximation of how much it's going to be. I'm not going to actually add it up. They added it up right there for us. Okay, so if I was actually adding this up, I'd say, okay, about $5 and about $1. I'm going to call that like $1.25 if I added my coffee and my sales tax together. So I'd say that I'm going to spend somewhere around $6.25. So I'd expect my answer to be somewhere around $6.25. So So when I type this onto my calculator and I get 625, I know that I misplaced a decimal place and I need to go back and relook at my answer. Okay? So just when you're adding something, guys, that's all we're doing. I just want you to approximate everything. So everybody sees the sandwich, $4.95, that's about $5. Everybody sees the coffee, it's almost $1, sales tax almost 50 cents. So you might say 5, $1 makes 6, 50 cents, 6.50. So you might say 6.50. So long as your approximation is going to be, accurate, don't round 50 cents to $1.
Wait a second,
Okay.
you said on coffee, the tax would be like 50 cents?
No, it's a tax on the whole thing.
Oh, are we talking-
Sales tax on the whole purchase. So that was, yeah, that wouldn't make any sense, right?
Yeah.
50-cent tax on an 88-cent purchase, it's taxing out the wall. Okay, so that's basically all we're doing. Go ahead and flip page. Go to the next one. We're going to examine a scenario, if I can get rid of this page. All right. So for each scenario given below, determine the answer is exactly, approximately, and estimated. So I want to kind of review over what the difference between approximately and estimated is. If we're estimating, we have to round up or we round down, right? Always. So an estimate uses this stuff right here. So let's just write these down, the difference between approximations and estimates. An approximation or an estimate is always less accurate than the exact answer. Exact answer, you just go ahead and do the math. Okay? So an approximation to a quantity, let's go approximate. And then we're going to do estimate. Now, most people hear these and think they're the exact same thing. So let's just see if we can find some differences between the two by examining what they're doing in their each scenario, right? So, on A, we're going to just do problem A here. So Cheryl has confirmed 143 guests for her party. She thinks that each of her guests will eat about half a pound of brisket. So she's trying to figure out how much brisket to make. So she decides to order half a pound by 150 people. She rounded to 150. Why would she round to 150 instead of 140?
Because you better have too much than too little.
Right. You would rather have too much than too little for people to eat, right? So she chose to round up. So in her particular problem, she wanted to round up and then multiply that by 0.5, which is just cut it in half. She finds out she needs 75 pounds of brisket. So in order to decide how much brisket she needs, Cheryl rounded her number to 150 to make sure that she had more than enough necessary. Also, her determination that her guess would be about a half pound is also an approximation. She's guessing, right? So she guessed that they would take about a half pound. Since different people will eat different amounts, this is an example of estimation. So problem A would be an estimation going off of the way the book explains it. So we're going to try to figure out if there's a difference. So I'm going to read scenario B and then we're going to talk about it. John received 4 identical boxes of best-selling books at his bookstore. The first book contained 12 copies of the book, so he figured that the shipment included 48 books. Now he's going off of 4 identical boxes. Each one would have 12. He thinks he's going to have 48 books. I would hope that he knows how many he ordered before he received them. However, let's see what we're going to do to examine this one. The number of books in each box is about 12, right? That's what we think. 12 is an exact number. And John will find out a fraction of a book in one of the boxes. We'll not find a fraction of a book in one box, right? He's not going to find, oh, there's a third of the book here and a third of the book there. So the number of identical boxes, 4, is also exact. Therefore, there is an exact answer when he goes to it. So, talking about differences here. Cheryl, she rounds to 150, so she rounded. So we'll go ahead and say that she rounds, okay? And then it says that she thinks that they're going to eat about a half pound, so she estimated, right? There. I didn't write exact. So we're looking at the difference between approximate, estimate, and exact. So the first problem which was an example of an estimation, right? She rounds something, and then she goes ahead and she estimates it. And putting those two together, we get an estimate. Second one, he has exactly 12 books. He has exactly 4 boxes. So when we multiply 4 times 8, we are assuming that that is the exact amount in each book, or in each box. So that would give us an exact answer. So exact answer would deal with only facts. Deal with only facts. Now, I know you guys should know that, so I'm not going to hit it too hard. But I'm going to move to example C, and if we can find out a difference there. Oh shoot, I put that on the wrong one. Okay, so on C, holy moly, anybody know how to pronounce that name? Lamani, sure. Lamani made a flag in the shape of an isosceles right triangle. Isosceles means how many congruent sides? 2. Okay, isosceles means 2 congruent sides. Right triangle means it has a 90-degree angle. She wants to put trim along the edge of the flag, so she measures each side with a ruler. She finds that each leg measures 10 inches, and the hypotenuse 14.1 inches. Okay, so she is measuring this to get an estimate for how much, or to get an idea of how much border she needs, right? She wants to put trim along the edges of this flag. So, even if the legs were exactly 10 inches, let's talk about a isosceles right triangle and draw it out here. So, isosceles right triangle says that this is congruent to this, and then, bam. Okay? So, if this is 10, and this is 10 inches, and she measures this from here to here as 14.1. Now, I, at first reading this, would say, well, that's an exact answer, isn't it?
Would you use the Pythagorean theorem? Is that what you would?
Right. Well, the Pythagorean theorem disproves her idea of this being 14.1, because the Pythagorean theorem would say that this is a squared plus b squared equals c squared, right? Well, if I solve a squared plus b squared equals c squared, I get 10 squared plus 10 squared equals c squared. So I'd get 100 plus 100, right? Now I have 200 equals c squared. So how am I going to get c by itself? I can't divide it.
Find the square root. Yeah.
Square root, right? I'm going to square root it. So if I want to get rid of a squared, I must square root it. They are inverses. So just like the opposite of addition is subtraction and the opposite of multiplication is division, the opposite of squared is square root. So we would get what as an answer? Incorrect. There you go. So, looking at it, let me see if I can get it to show up on my screen here. The square root of 200 is a kind of long decimal. So, her measurement was 14.1, which is probably going to get her close enough, right? However, it's not an exact number, is it? It's actually rounded. So she rounded it to 14.1. So, in reality, when she presented herself as an exact number, it wasn't an exact number because it wasn't a perfect triangle. So this is a approximated number, or a rounded number, so it would go into approximation. So let's talk about the differences between approximations and estimates. Okay, we're going to kind of establish our definitions. Safe to say that estimate involves estimating, right? Guesswork, in other words. So estimates involve guesswork. They deal with a bit of guesstimation. It's redneck word of the day, guesstimation. Deal with guesswork. It deals with guesswork, not literal rounding, but more along the lines of guessing. We don't follow the rules of rounding because she rounded 143 to 150. She used a little bit of common sense, said, I want more, not less. However, in approximation, we always use the rules of rounding, right? use the rules of rounding. Okay, so the big differences between approximation and estimation are, one is using rules, right? General guidelines that we've established. 5 and up, round up. 4 and down, round down. Those are the guidelines. On estimation, the guidelines is whatever really kind of makes sense, right? It's using your common sense. So under dealing with guesswork, just put like comma and then put common sense in there. Now, common sense ain't so common, so what you think makes sense may not be the same as the person next to you. So if you're going to use estimation, you got to have a justification with it. So if I say I'm going to round to 150 and I ask you why, you say because I'd rather have more than less. Okay, that's fine. Cool. I'll totally agree with that. If you say I want to round down to 140 because I got people that are going to eat too much and others that are going to eat too little, we're just going to use proper portions, then okay, that's fine. But you have to justify why you're going to do it. Okay? So, A was approximation, B was our exact answer, and then C was our estimated answer. So if you ever go back and look at them, you can kind of discuss why. Okay, go ahead and flip page. We're going to do some more, and this deals with a lot of small fractions. So when we're looking at fractions, I want you guys to keep thinking about how to round them, how to estimate them, how to approximate them, so we can just check our answer when we get to the end. Okay? So they say that they're going to talk about probably perimeter here. Diagram shows a cell phone. That's why I grabbed my phone. Ruler set along its base and its height. Determine the area of the phone's screen. So this is what I always thought was interesting, because I always want to predict what the new phones are going to do. And I've been telling Jen and my brother that, man, it would be really genius to them if they utilize this whole screen, because if you look at this, you can't use this part of your screen. You can't use this part of your screen. Wouldn't it be genius if you had that much more screen? Let's look at it. If you had a whole nother centimeter of screen on top and a whole nother centimeter of screen on bottom, right? So if they utilize that much more screen, we can use just a quick estimation. So I'm going to take my ruler. I'm going to do it in inches first. So here we go. I'm looking at, write these numbers down. It's going to be from our literal phone here. 5.5 inches height-wise. It's 5.5 inches height-wise. Okay? Now, of course, this is an approximation. I'm not going down to the nitty-gritty here. And then it is, looks like 2 5/8 widthwise. 2 5/8 widthwise. Okay, so this is the measurements of the actual screen. So annotate that, actual screen. So the actual screen was, tell me the measurements again.
5.5 inches by
5.5 by 2 5/8, right? Now let's look at the screen that's actually lit up. So this one would be the lit up screen. Okay, so going from there to there, we're at about 4 1/16. 4 1/16. So lit up 4 1/16 of an inch. Now widthwise, let's see what that gives me. Hard to see. 2 and that's a quarter. 1, 2, 3, 4, 5. 5/16. 2 5/16. 4 1/16 tall, lit up. Alright, so this is what I got. You should probably match me. This is 5.5 inches by 2 5/8 of an inch. 4 1/16 of an inch by 2 5/16 of an inch. Okay, so I'm going to discuss area. I'm going to talk about how much screen space that they have that is currently being wasted, in my opinion. By the way, the new iPhone comes out today, if you're curious. Okay, here we go. I'm just going to do a rough estimation, okay? 5.5. That's a number I can deal with. Why do I not want to round this to 6 on a phone? Because I want to be as close to exact as possible, but I'm going to do some estimation here just so I can quickly do it in my head. I don't want to use a calculator. So if I did another 1/2 inch, this is how far it would be. Who's got a crazy big phone? Okay, so if you had a crazy big phone, let's just compare this iPhone-wise. Mine's a 6S. If I was talking about the 6 Plus, that's the difference between the 6S and the 6 Plus. Okay? So, this is what another 1/2 inch would get me. That's why I don't want to round up. Okay? That's why I wouldn't round up to 3 inches on the width. And I wouldn't round this to 6, because 6 inches is going to be right there. Well, you can't even see it. See, it doesn't fit on my screen. Okay? See, it's humongous in comparison. So, I just wouldn't do it on this small of an object. Okay? So, round appropriate to the size. Or approximate. So, we're going to estimate here. I'm going to estimate this is 5.5, so 5.5. And I'm going to take this to about 2.5. So I'm going to go ahead and multiply that by 2.5. Those are both numbers that I think I can do in my head. Okay? So, on this one, 4 1/16, yeah, I'm rounding that to 4. 2 5/16, I'll probably go ahead and round that up to 2.5. Because I'm just getting an estimate of how much screen space is wasted here. It's not huge when you look at it in inches. So let's just find out how much it is. So, the way I'm going to do this is I'm going to think of this as a quarter. Okay, I'm going to think about 25 as a quarter. If I had a quarter and I had 55 quarters, how many dollars would I have? That's how I always think about it. Okay? So if you can do it in your head, you do it in your head. If you can't do it in your head, you do it on a calculator. But we want to be able to do numbers that are capable of being done in your head. If you had 55 quarters, then you'd have $13.75. Okay? So that's what I'm looking at. That's why I think about money, okay? So it's $13.75, but the real label, I always think about it in money, but the real label is inches squared, right? Inches squared. Now, 4 times 2.5, that one's a lot easier to do. It's 10, right? 10 inches squared. Now, I wanted to find out how much wasted space there is, so I need to find the difference between these two things. So I'm going to go ahead and subtract them. So I get 3.75 inches squared. That's a lot of wasted space. Okay, that's just estimates. Okay, if you look at the screen on your iPad, everybody's got an iPad, right? Imagine if your screen extended all the way to the borders of your casing. You'd have a lot larger screen, right? Okay, so that's just using estimation. Instead of doing their example, y'all guys now have another avenue of looking at it, okay? So, go to the next one. All right, on example B, it has a table of populations, okay? So, example B starts with a table of populations. The population shown for Jackson, Juniper, and Pinewood. These are 3 nearby cities in close proximity to each other. It says find both an exact answer, so here's our exact, and an estimate. I feel that if you're going to find an exact answer, you should probably find our estimate first. So let's look at that chart. Everybody look at the chart. Jackson. About how many people are in Jackson? Look at your chart.
324,000.
That's an exact answer. I asked how many about how many are there in Jackson. Now I want you to talk in your group because I want to see if we get different answers. So talk to just your group first. Tell me what you would think to approximate that to. What's your percentage? Go over there. Yeah. Okay, you should have an answer by now. What do you think?
324,000.
324,000. That's what he estimated. What about you guys over here? Group 1. What do you think? What?
The whole thing or just the first one?
Just the first one. I just want to know what the first one was. 324? Okay. What about you guys? Y'all chose 324,000? Mark, did you 324,000? I would have chose 325 because I know how to add 25s up. So I would just put everything in groups of 25 because the next one I'd look at and go probably 130. I know how to add 25s. It's really easy for me. So I'm just trying to point out that there's more than one way to do it. Okay? So you guys all said 324, so I'm going to go ahead and go 324. So it's safe to say that we're going to add up to the thousands, right? So 324, 1, 2, 3, 1,000. Looking at Juniper, talk to your groups. What do you think? 130? Should we go to 129? Are we following general rounding rules here? Remember, estimate doesn't follow general rounding rules the whole time. You can do what you want with it, what makes sense to you. Talk to your group. Okay. What did we decide here? Group 1?
130.
You chose one? 130. What'd you? Y'all chose 130. What'd y'all choose? 129. What'd y'all choose?
I said it's got here.
It's okay. It's only one number.
Said 130.
Sure. Okay, so I have two answers, 129 and 130. I'm going to ask the group with 129 to justify your reasoning behind that. Go ahead. Why do you choose 129?
I started with the lower one. Since 7 to 4 to 5, I rounded the 9 up to 0, and then rounded to 2, and I rounded to 2, rounded to 3, and I rounded like that.
So you went ahead and did the general rounding rules on the 9, but ended up with a 129.3. And you're just like, well, that's still not high enough, so we're just going to go to 129. Okay. This is why I would agree more with 129 than 130 for what y'all guys chose to do. On the first one, you chose to round to 24, which was down, right? 129 would follow that same exact rule, so you would have rounded 1,000 differently than you would have the time before. So I'd want to remain consistent with the way that I was choosing my rounding, or my estimation, okay? So to remain consistent, you would have chose 129 rather than 130, just because you're trying to be consistent. Pinewood, talk about it. Got it, eh? All right, group 3 has got an answer as to why. Let's see what they say. What did you decide?
503.
503, okay. Why?
Because 8 is way bigger than 5.
'Cause 8 is much bigger. It's more than halfway between the 5 and the next biggest thousand. So he chose, go ahead and round that baby up. Okay? So it'd be 503,000. Now in reality, I didn't need to really write down all these thousands because I could have just added up the first 3 numbers on each of those and got my estimation, right? Another option here, because it just said to estimate, this is what I would have done. I would have said 325 plus 130 plus 500. That's what I would have done, just to make sure that I added my stuff up correctly. The reason I would do this is because I know 500 and 325. That's 825, right? And if I know 825, it's really easy to add this next one up, so I get 955, which is a lot easier to add than 324, 129, and 503. in my head. Okay, that's why I think estimation, I don't want to use a calculator. I want to do this as fast as possible. Okay? And then I'll just tack on the zeros at the end and put a label on it. Population, persons, census, I don't know. Whatever you want. Now, for an exact answer, we would just literally add these all up, right? So an exact answer, I take 324, 109, and I add it to 129, 297. Then I add that to 502, 864. And I get my whole big answer, which is 954, 270. I'm going to compare these. That's why I'm going ahead and doing them. Okay? This was my estimate, 955, and theirs was 954. It's pretty close. Y'all's estimate, I don't necessarily like doing that one in my head. What was it? 956,000. 1, 2, 3. So looking at the difference between these, I'm not saying one way is better than the other. Okay? That's not what I'm trying to get at here. But if I was to look at the two different ways to do it, you would say this one was more accurate. Okay? I'm not saying one is better than the other, I'm just saying one is more accurate. Okay? Any questions? Comments, concerns? Okay, you have the practice, you can get to work on it.